In the last video, I discussed about how do we find the area under a curve by using the numerical method, not using any of the formula of the techniques of integration. Without using them, how do we find out the area under the curve? By one of the famous numerical integration technique that is called Trapezoidal Rule, in which we divide the domain or the distance or the interval a to b into n equal parts, and we draw the rectangle or we draw the stripe. Okay, in each stripe, if we join the top by a line, the top part of the stripe by a line, then you will get a trapezoid, right? And then we found the area of each of the trapezoid, and then we added them, and we got that we got the formula for the trapezoid rule to find out the area under the curve. Okay, so in that case, the top part of the area was approximated by a line, right? The top part of the area was approximated by the line, because what we did last time was we made, for this one we joined by a line like that. For the other one, we join by another line like that, and then so the area under this curve, that black curve, is approximated on this interval that we denoted by this is x0, this was x1, x2, and so on, right? And this was x of n minus 1, and then x of n, that's what we denoted. And each of this stripe, the area under this curve for this stripe, is approximated by the trapezoid formed by these three sides, and then the top side as a line. Although this curve is not a line, this is a curve, right? And then each of those are approximated by the line. All right, so that was the trapezoid rule. But instead of approximating by a line, here what we do is we will approximate by a curve. So instead of a line, what we will be doing is we will be approximated by a quadratic function, that is a parabola, meaning that we will approximate the area under this curve between x0 and x2 by a quadratic function, let's say like that. You see that? Quadratic function like that. Similarly, other 2 points, you will draw another quadratic function, and then area under this black curve we will approximate using the area under this quadratic function. Okay, so what that means is, if you are asked to find out the area between x0 to x2, okay, I'm picking the two stripes at the same time, and then f of x dx, what we will be doing here is basically we will be writing x0 to x2. Let's say that this quadratic function is a x squared plus bx plus c and then dx. So because we don't know how to find out the area under this black curve, that's why we are using the approximation method, meaning that we're saying that the area under this black curve in this interval x0 to x2 is same or approximately equal to the area under this pink curve in this interval. That's what we're doing. Okay, and the equation of that pink curve, we are assuming that ax squared plus bx plus c. So if you do that, what do you get? If you integrate, then you get that this will be a x cubed over 3 plus bx squared over 2 plus cx. You see that? And then you get that the limit of integration is x0 to x2. Okay, so what I want to do is I want to get rid of the denominator here. So I want to write this common denominator will be 6. Okay, that 3 times 2, and then there is 1 in the denominator, so the common denominator is 6. I want to write 1/6 here. Okay, and what you get is 2ax cubed plus 3bx squared plus 6cx. That's what you get. That makes sense? Now you plug in the limit, so that is x0 to x2. So what you get after that is 1/6. If you plug in the limits here, you will get like this: 2a, and you write x2 to the cubed minus x0 to the cube plus 3b x2 to the square minus x0 to the square. I'm just plugging in the limit, right? That's what we do. You plug in the first, for each of the x, you plug in the first, the upper limit, and then do minus, and you plug in the lower limit. That's what I'm doing here, right? And then plus 6c, and then x2 minus x0. That's what you get. Okay, now what is the formula for so x2 cubed minus x0 cubed? It is like a cubed minus b cubed, right? The formula will be x2 minus x0, and then x2 square plus x0 x2 plus you get x0 square. That's the formula. And then what is the formula for x2 square minus x0 square? x2 square minus x0 square will be x2 minus x0, and then parenthesis x2 plus x0. That's what you get. So you see that if you write the factors of this and that, you will get x2 minus x0 as one of the factor, right? So that guy, this guy, and then this guy, and you see that this one also has that. So you can take that thing out. Let me take that out. You can write x2 minus x0 over 6. Okay, what is left? If you take that out, then 2a. What is left is that part, right? So that will be x2 square plus x0 x2, right? And then plus x0 square. That's from the first term, plus 3b. What is left is x2 plus x0 is left, right? When you take that out, that thing out, right, what is left is this one on the second one, and then plus 6 times c. That's what you get. Are you guys okay? Now, oh, by the way, that square is inside there, okay? That square is x0 square. x0 square. That's what it should be. Okay, guys? Now, you see that what I'm going to do here is, because this is 2a, right? So you can write this thing plus that same thing twice. You see that? So you can write like this. You can write x2 minus x0 over 6, right? And then here what you can write is, you can write x2 square, okay, plus x2 square plus 2a x0 x2 plus x0 square plus x0 square. What I'm doing is I'm distributing this, but oh, by the way, there is 2a, okay, I should not forget that. By the way, not 2a, I should write just a. So ax2 square plus ax2 square is 2ax2 square. Similarly, ax0 square plus ax0 square is 2ax0 square. Plus, what I want to do here is plus, I want to write like this, bx2 plus bx0, okay? And then what is left is 2b x2 plus x0. I'm just writing in a little weird form, right? I'm writing c plus 4c. You will see why I'm writing this, okay? So don't worry now. So you will see that in the next step. So what I'm trying to do is I'm trying to write f of x, because I'm using f of x in this interval. I am approximating that f of x by ax squared plus bx plus c. So in this interval between x0 and x2, I am approximating f of x, this black curve, by this quadratic function, that is the ax squared plus bx plus c. That's why I'm writing approximation or the similar, okay? That's what I'm doing. All right. So what I'm doing next is, look at this, ax2 square and then bx2 plus 1 of the c. So you see that ax squared plus bx plus c, that will be one term. And then another term that I am going to underline is, that is, you see that ax0 square plus bx0 plus c. I will write that one, and then I will write the remaining one. Okay, so what I'm going to do here is, oh, by the way, that's the, let me use the same color here. So that will be x2 minus x0 over 6. And then I'm writing them together, ax2 square plus bx2 plus c. I'm writing those underlines, and then plus I'm writing the green underline next, ax0 square plus bx0 plus c. And now I want to write the remaining one. I want to write ax2 square, okay, plus 2ax0 x2 plus, this is x0 square. Okay, I'm writing what am I writing next is I'm writing this one, and then this one, and then this one, and then next I want to write this one, and then I want to write that one. That's my plan. Okay, now what is left? I wrote that one. Now I want to write plus twice b x2 plus x0 plus 4c. That's what I'm writing here. Okay, so what do you get? So this basically, this thing is f of x2, right? Because f of x is that. So this will be f of x2. This will be f of x0, right? And then this guy is what? If you take a out, what do you get? x2 square plus 2 x0 x2 plus x0 square. That will be x0 plus x2 whole square. Okay, that's what we will get. Okay, let us write on that thing. So what I'm going to write is, you can write x2 minus x0 over 6. Okay, this is f of x2 plus this is f of x0. Okay, and then plus you can write a x2 plus x0 square, because if you take a out, you will get x2 square plus 2 x0 x2 plus x0 square. So that will be basically the perfect square format, right? And then plus twice b, and then x2 plus x0, and then plus 4c. That's what you get. Okay guys, so what I'm going to do next is basically try to write in a little bit simplified format. Okay, what that format would be is, I'm writing like this. Let me do a little bit of idea here. I'm using a little bit of trick. It's not very tricky though. x2 minus x0 over 6. Okay, and here you get f of x0 plus f of x2. I'm just writing that f0 first, no problem, right? And then plus I want to take 4 out. Why? Because I want to write this term as that function form. Okay, that's what I want to do. That is why. If I take 4 out, what do you get? You get you write a, and then x2 plus x0 square over 4, right? Because if you distribute that, you will get the same thing, plus 2b x2 plus x0 over 4 plus c. I'm just taking 4 out because that c has 4 there, so I'm taking 4 out so that this thing will go under that, right? If you simplify, what do you get? x2 minus x0 divided by 6, right? And then you write this is f of x0. By the way, this should not be that long or big parenthesis here, right? This will be like that. And then plus, you see, plus f of x2 plus 4. I can write like this, a, and then because I want to write the whole square, right? x2 plus x0 over 2 square. Do you agree with that? What I'm doing here is, because there was 4 outside the square, so I put inside and then wrote that 2 whole square. That is basically same as x2 plus x0 square over 4. And similarly here, you can write b and then x2 plus x0 over 4, and then plus c. That should be 2, right? Because I divide that. That should be 2. Do you know why that is 2? That is 2. Why? The reason is this, because 2, there is 2 there, there is 4, so you divide. That's what you will get. Okay. By the way, look at this. What is x0 plus x2 over 2? This is x0. This is x2 divided by, that's the average of x0 and x2. That will be x1, right? Because that's the mean of the x0 and x2. So that will be x1. So you can write basically x1 is equals to x0 plus x2 over 2. That's the midpoint, right? So I'm writing that x1. So what do you get then? So you get basically x2 minus x0 over 6. And then this will be f of x0 plus f of x2 plus 4. You can write ax1 square plus bx1 plus c. But what is that? ax1 square plus bx1 plus c. That will be f of x1, right? So you can basically write this as x2 minus x1 over 6. Okay? And then write down f of x0 plus 4 f of x1. Okay? and then plus f of x2. That's what you get. You see that now? So this is the thing. Let me tell you this. So basically we divide the interval a to b into n equal parts. N equal parts, right? So what is the width of each of these sub interval? What is the width of this one? This one will be, the total length is b minus a. So the total length is b minus a, and you made how many of them? N. So that is b minus a over n is the length of each of those sub intervals, right? But how much is x2 minus x1? X0. How much is x2 minus x0? x2 minus x0 is 2 of that width, right? So the twice the double of the width. B minus a over n is the width of one of them, but x2 minus x0 is twice of that. So how can you write that then? So you can write it is like 2b minus a over n and divide by 6. So you can write that as 6n, right? So that x2 minus x0 is 2 times b minus a over n, and then that 6 is still in the denominator, right? So what do you get? F of x0 plus 4f of x1 plus f of x2. You see that? Now, so if you divide by that by 2, then it is 1. That will be 3. So what will be the final answer for that interval? For that interval is hence you got x0 over x2 and then f of x dx, meaning if you want to find out the area under that black curve between x0 and x2, this is same as you can write how much you get, b minus a over 3n, b minus a over 3n times f of x0 plus 4f of x1 plus f of x2. This is what you get. This is for the first two interval, first two width, right? First two stripes. If you find out the third and fourth stripe, what do you get? You think, what do you get? If you write like x2 through x4, this is x3, this is x3, this is x4, right? How that look like? F of x dx. It will look like this: b minus a over 3n, and then it will start from the left. That will be f of x2 plus 4f of x3 plus f of x4. I'm just using the same technique, okay? If you use the same technique to find out that and continue that, okay, so you will get like that. But at the end, if you add all those, if you add this one, if you add this one, if you add all these terms, this is what you get. On the left side, you are adding x0 to x2, x2 to x4, x4 to x6, x6 to x8, and so on. Okay, if you do that, you will, if you add all those, you will get like this: a to b f of x dx. That's what you will get on the left side if you add all those plus 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 like that. On the right side, this b minus a over 3n will be common to all of those. B minus a over 3n will be common to all the pieces. And then you see that, what do you get? You get f of x0 plus, you get that the second term will be 4f of x1. Third term will be f of x2 plus f of x2. You will have to add that. So this will look like what? This will look like plus 2f of x2. Okay, and the next term will be plus 4f of x3 plus, and you continue that way. Okay guys, so ultimately what will that look like then? So you will, it will look like if there are even number of outcomes, or if there are even number of terms. You see that if there is even number, if it is even, okay, then it will be just the first one and last one will be the f of x0 and f of xn. But the middle term, if it is odd subscript, then you will have 4 times. If it has even subscript, then you will have 2 times. Okay, so I'm saying that suppose n is even. So if there n is even, right, so the last one is even, like xn is like x20 or x50 or x100, like that. So what you get is plus the second one from last will be odd because the n is even. That's why it will be 4f of x n minus 1 plus the very last will be like similar to f of x0. It will not have anything like 2 or 4. It will be f of xn, and that. So this is the Simpson rule. Simpson's rule. So if you are asked to find out the area under the function f of x using the Simpson rule, that's the formula we will be using. Okay guys, that is called the Simpson rule. All right, that's all about the Simpson rule. So what I'm going to do next is I am going to present example using both Simpson rule and the Trapezoid rule. Okay guys, so what I'm going to do next is I want to do question number 9. Okay, question number 9 from the book. So I want to do question number 9 from the book. So that is example. It says question number 9. Okay, so what it says is use. So it says use trapezoid rule, trapezoid and Simpson rule both, and also find the error, and also find the error. So how do I find the error? So I will be finding the exact integral using the integration formula, and find the difference between the total area under the curve by Simpson rule, by exact method, and then by trapezoid rule, and then the error will be difference between a rule, the area obtained by the rule, certain rule, and then minus the exact formula. Okay, so this is the question. Question number 9 is 4 through 9 root under x and then dx. So you want to take 9. So it's you want to take 8 intervals. Okay, so how much is the exact value? So let me find out the exact value. So the exact value, so exact area will be, just find out the integral of that, right? So 4 through 9 root under x dx is equals to, what is the integral of that? That is x to the 1/2, right? So x to the 1/2 plus 1 is 3/2 over 3/2, and then this is 4 through 9, right? So what do you get? 2/3, right? 2/3. So x to the 3/2 and then 4 through 9. So what do you get? You get 2/3, right? And then x is, let's do 9 to the 3/2 minus 4 to the 3/2. That's what you get, right? So what is the 9 to the 3/2? 2/3 times 9 is 3 squared times 3/2, that is in the exponent, minus 2 squared times 3/2. What do you get? You get how much? You cancel that square and half there, and then square and half. What do you get there then? It is 2/3 is there, right? And then 3 to the 3rd is 27. You see that? 27 minus, and then 2 to the 3rd is 8. So what do you get? 27 minus 8 is how much? That is 27 minus 8 is 19, right? So 27 minus 8 is 19, times 2 is 38 over 3. If you use calculator for that, you will get 12.6667. That's what you'll get. So if you find out the integration techniques that we learned, that's what you do. But again, what is the main purpose of the numerical integration is, sometimes we cannot find out the integral by using such integration techniques. Okay, in such case the numerical method will be lifesaver. Okay, that's why I'm doing that's where we use the integration techniques, or the numerical techniques of integration. But here I'm just showing by taking a simple example, how do we use the numerical integration. Okay, so next I want to do is trapezoid rule. Let me use trapezoid rule. Trapezoid rule. So for the trapezoid rule and Simpson rule, we need to find out what is the b minus a. So what is a? A is 4, b is 9, n is 8. So what is b minus a over n then? B minus a over n will be how much? That is 9 minus 4 over 8, right? That will be how much? 5 over 8. That's what you get, right? 5 over 8. Now, so what I'm going to do next, and also, so you see that you have in the trapezoid rule, what is the formula for the trapezoid rule? A to b f of x dx is equals to, the trapezoid rule is, so it is b minus a over 2n, b minus a over 2n times, the formula is f of x0. The first and the last will have just f, other have 2 times, right? Plus 2 times f of x1 plus 2 times f of x2, and then plus so on, and then plus the last one will be f of xn, right? That's what the trapezoid rule is. Where how do I find out xi then? Xi is a plus I times x0. That's how we find out xi. Okay, so a plus I times a plus I, oh, not x0, that the I times that thing, delta x. Okay, I times delta x, that is same as, that's another notation. Okay, that's delta x is the width of each of the stripe. That's the delta x, that's the notation. Okay, so if you want to find out x0 is that x0 is a, right? And then so how do I find out x1? X1 will be a plus 1 times delta x is that a plus 5/8, and then continue that way. Okay, so let us do that then. So what is the integral, that 4 through 9? So 4 through 9 root under x dx will be, what is b minus a over 2n? B minus a over n is 5 over 8. B minus a over 2n is, you multiply the denominator by 2, so it will be 5 over 16, right? And then what is f of x0? So by the way, what is f of x? So f of x is, so here f of x is what? F of x is root x. F of x is root x. So what is f of x0? X0 is a, right? So this is x0 is same as a. So f at x0 is how much? F at x0 means, what is x0 is root x, right? If you replace by 4, x replaced by 4, then root 4 is 2. That's what you get. So let me use the same color. The first one will be 2 plus, okay? So 2 times, what is f of x1? So x1 will be how much? X1 will be a plus 1 times delta x. That will be 4 plus 1 times 5/8. So how much is that? So that will be, x1 will be, so let me write down that. Okay, so you will get x0 is, let me use different color for that. So you got, so x0 equals to a equals to 4. X1 will be how much? X1 will be a plus delta x. That will be 4 plus 1 times delta x is 5/8. How much is that? So you got 8 times 4 is, so if you do like this, 8 times 4 is how much? 32 plus 5, 37. 37 over what? 8, right? So what will be the f of x1 then? Because f of x is root x, so f of x1 will be root under that, right? Root under 37 over 8. Okay, similarly find out x2. X2 will be what? A plus 2 times delta x, because you see that I'm using that formula. Okay, so that will be 4 plus 2 times 5/8. What do you get that one? So you divide that, so that will be 10 over 8, that is same as 4 over 5, right? So 4 over 5 plus 4, it is like 4 plus 4/5. That will be how much? 4 sorry, so it will be how much? So 5, not 4/5, 5/4, right? 5/4, not 4/5. You get 5/4. So 5/4. So if you do that, you will get, I think, 21 over 4. So what will be f of x2 then? Will be f of x is root x. So if you replace x by x2, that is 21 over 4. That will be root under 21 over 4. And you continue like that, x3, x4, x5, x6, x7, and then x8. That's what you should be doing. Okay, so what do you get? Let me plug in that. So 2 times root under 37 over 8, that is f of x1, plus this will be 2 times f of x2 is root under 21 over 4. Okay, similarly you will get 2 times, for x3 you will get 47 over 8, plus for x4 you will get 2 times 26 over 4, root under 26 over 4, that is x0, x1, x2, x3, x4. Now you need 4 more, right? So so the next one will be 2 times root under 57 over 4. Okay, all of them are under the root, plus 2 times root under 31 over 4, plus 2 times root under 67 over 8. By the way, this 57 is over 8, okay? 47 over 8. So you see, one of them is 4, another is 8, like that. And then the last one will be just 3, because last one will be x8. x8 will be x0 plus 8 times delta x, right? And then that, you see that, if you continue that way, let me use the same color. x8 will be a plus 8 times delta x. So you will get 4 plus 8 times 5, 8, right? That will be 8 and 8 will cancel out, so 4 plus 5 will be 9. So what will f of x8 will be root under 9, that will be 3. That's what I'm doing here. So 5 over 16 times that. Oh, by the way, let me use that same color there. So 5 over 16 times all that. So if you add this using the calculator, all these using the calculator, you will get, I got 12.6640. That's what I got. Similarly, I want to use the Simpson rule. Let me use different color. So Simpson's rule. Okay, and all the x0 and then all these things are the same. Okay, x0, x1, everything will be the same. All right. So what I'm going to do here is all these value, you find out that they will be the same. Only the formula is what? Formula will be a to b f of x dx. The formula is like b minus a over 3n, not 2n. It is 3n now. Okay. And then you have, the first one will be f of x0. Okay. The first one will be f of x0. And second will be, if it is even, from the second, if it is odd, it will be 4 times f of x1. If it is even, it will be 2 times f of x2. For odd, f of x3, 4 times f of x3, plus 2 times f of x2, and so on. Okay, and then you do plus the last one will be even, so that will be f of xn, right? The before that it will be odd, so it will be 4 times f of x n minus 1. That's what you get. That is the formula, right? So in our case though, it will be what? 4 through 9 root x and then dx. So b minus a over n is 5 over 8, but we need to find out 3n. So it will be 5 over 3 times 8 will be 5 over 24. What is f of x0? It is same as the previous one, 2 times 2 plus 4 times f of x1 is that's the f of x1, right? So that will be basically root under 37 over 8 plus, so the next one is 2 times, right? Next one is 2 times, so 2 times f of x2. What is f of x2? So f of x2 is the same, so the same as that one, right? So this will be root under 21 over 4 plus 4 times, what is the next one? Root under 47 over 8 plus 2 times root under 26 over 4 plus 4 times root under 57 over 8 plus 2 times root under 31 over 4. Because you see that some of the terms are the same. That is the reason. You see that on these two formula, you see that f of x0 is same as f of x0 here. Okay, and then 2f of x2 and 2f of x2 are same. That's why we have the same types of term there. Okay, and then plus what is next? 4. By the way, let me use the same red color, pink color there. Plus 4 times, what is the next? So we have for 31 by 4, that is 2. So 4 times root under 67 over 8 okay, and then plus you have the last one is the same as the previous one, right? This one and that term are the same. So if you use calculator for this, you get 12.6667. Look at that error. Look at that, the exact value. So let me find out the error here. Error by Simpson rule. Number one, Simpson method, let me do the trapezoid method for, okay, trapezoid method. So error from trapezoid method is absolute value of the difference between the approximated value 12.6640 minus the exact value we got 12.6667. That's what you get. Okay, so here you find out the error. So if I use calculator, I found the error by that is, let me find out that. So it is 12.6640 minus 12.6667 is 0.0027, because there is absolute value, we just ignore the negative sign. 0.0027, that's the error we found in the value of the area if we use trapezoid method. But if you use the Simpson method, so if you use Simpson's method, the error you got is 12.6667 minus 12.6667. In this case, we got almost zero error, right? Why I say almost zero is I'm just considering only the 4 decimal places. That's why I got almost zero, because they are perfectly the same up to the 4 decimal place. But if you take 10 decimal place, you will get like tiny error there, but it will be negligible error, very small error. Okay, that's how we use the integration technique. And the very important thing is, why do we need the numerical integration technique is sometimes it is very complicated if you try to use that exact method to find out the integral like we did here. So in that case, this is the method we use for any type of complicated function. And all the like calculator and all the softwares, they use trapezoid method or Simpson method, and there are other methods too to approximate the area under the curve. Okay, they use this technique to find out the area under curve or definite integral. Okay guys, thank you. So next thing we will talk is the error analysis. There is a certain method that how many terms do you need to make the error small, that kind of thing we'll be discussing in the next video.